Morning students. Today we are going to discuss about stability of half-filled and completely filled orbitals. Generally, if you take an atom, it wants to stay in their lowest form of energy. So the electronic configuration that we write for an atom corresponds to its lowest state of energy. This implies if electrons are in their lowest energy orbitals, atoms are stable. Because if the electron has higher energy, it gets excited and the atom becomes unstable. But certain elements like copper and chromium differ from their general configuration. The configuration of copper is found to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. And for chromium, the actual electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d4. But this appears to be the wrong configuration of chromium and copper as they exist in a different configuration. Let us find out the correct way of its configuration and the reason of that configuration. Before knowing the correct way of configuration for chromium and copper, we must know what's the reason for this to exhibit in different configuration. That is, half-filled and full-filled orbitals have greater stability than other configuration. This implies that there is greater chance of getting half-filled or fully filled orbitals by distributing any one electron, then such configurations are preferred. There are two reasons to explain why exactly half-filled and completely filled orbitals are more stable than partially filled orbitals. This is because of the symmetry and exchange energy. Let us learn these two reasons in detail. The first reason is the symmetrical distribution of electrons. Here towards the right hand side, you can see the cases where the distribution of electrons is symmetrical. And symmetry always leads to stability. Now let's see how symmetry leads to stability. If you consider the half-filled and fully filled configuration, the shielding of the electron is very less and thus they will be strongly attracted towards nucleus and thus atom becomes more stable in the case of half-filled and fully filled orbital. Now let us learn the second reason, exchange energy. Generally, electrons present in different orbitals of the same subshell tend to exchange their positions. The exchange of electron occurs as shown below. And such exchange leads to decrease in energy known as exchange energy. And greater the number of exchanges, greater the exchange energy and hence greater will be the stability. As the number of exchanges that takes place in a half-filled and fully filled orbital is maximum, thus the exchange energy will also be maximum, which results in maximum stability of the atom. Now let us come back to our original example of chromium and copper. Taking the concept of stability of half-filled and full-filled orbitals into account, we will try to write the electronic configuration for chromium and copper. First, let's see in the case of chromium. Here in chromium, if one electron from 4s subshell jumps into 3d subshell, we get an half-filled configuration. So the correct electronic configuration of chromium is said to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This configuration has more symmetry and maximum possible exchange energy. Similarly, in the case of copper, if one electron moves from 4s to 3d, then one orbital is half filled and another orbital is completely filled. So the electronic configuration of copper will be 1s2, 2s2, 2p6, 3s2, 4s1, 3d10. And this configuration makes copper more stable. Here you have the list of some elements as showing exceptional electronic configuration.